To keep you fed until Ares 4 arrives.
Okay. Glad to hear it. Really looking forward to not dying.
Hello, I'm Axel and I will be presenting about testing movie scenes using physics. Before we start to proceed to the calculation to prove the movie clips using physics, I will be stating my first and second hypothesis for the first clip and second clip. For the first clip, if the actor has fallen from the certain height, then the movie scene is fully logical. However, an exception for its parachute part, which seems very illogical. For the second clip, if the actor is on Mars, then the travel speed of data is not as fast as it's shown in the movie. For the first scene, for this one, I picked a scene of Hello Jump by Tom Cruise in the movie Mission Impossible. From the video, I have retrieved some data, such as the actor drops from the height of 7,620 meters above ground with a mass of 77 kilograms in 120 seconds. I have used a free generator for this free fall because the calculation for this free fall in particular with air resistance is a bit tricky, so I need the help of a generator. So I input the mass, which is 77 kilograms, and I put the altitude of 7,590 meters. Please be noted that the 30 meters have gone to a time of parachute, which is 30 meters above ground. The gravitational acceleration would be 9.8 meters per second, and this is the air resistance coefficient. And then from the generator, I got that the results are this. With the mass of 77 kilograms, with the altitude of 7,590 meters above ground, the time of fall would be 139 seconds, not 120 seconds. While the maximum fall velocity would be 202 km per hour and the terminal velocity of 202 km per hour. These are the steps which is written in the generator itself. Air resistance or aerodynamic drag force is a force that opposes the motion of a body in a free fall. The faster you fall, the higher the force is. It can be expressed by the following drag force equation. F equals to K multiplied by V to the power of 2, where V is the instantaneous speed and K is the air resistance coefficient, measured in kilograms per meter. The air resistance coefficient is dependent on quite a few factors. It can be calculated by the following air resistance formula. K equals to P multiplied by A multiplied by C divided by 2. This is the explanation on how the calculator works. The online calculator generator will do its own algebra in order to find the missing information, and these informations found will be compared with the information I've collected from the movie scene. If the time is 120 seconds, which is shown in the movie clip, the gravitational acceleration would be 13 meters per second, not 9.8 meters per second. And as we know, changing the gravitational acceleration is impossible to be done, considering that it's already a fixed number. And this is the results, as you can see here. And this is the free body diagram of the free fall. The first one would be the freefall itself. The freefall is very simple. It's just weight with nature of force, which nature of force would be some air resistance and stuff. And this one, the on parachute, 30 meters above ground. And from seeing this calculation to collected data, this scene is not fully logical. From the height of 7,590 meters plus 30 meters, 30 meters of parachute, its final velocity reaches 202 km per hour, not 193 km per hour, and it should have traveled for 139 plus 6 seconds. 6 seconds of parachute. The fall should have been 25 seconds longer. And in this scene, it's also shown that the character opens its parachute 30 meters above ground, which is very suicidal considering that base jumps, usually done by military, they usually opens their parachute minimally 148 meters above ground. This is the resource of the free fall calculator with air resistance. It's made by Bogdanasic, and it's uploaded on Omni Calculator. And then for the second clip, I analyze the clip of where in the movie Martian, where Matt Damon sends signal from Mars to Earth and vice versa, and it's shown that there are no pause on the when transferring the data, which I think it's illogical considering that wave travels at the speed of light and Mars took some time to reach with the speed of light. In this clip, it is shown that the actor communicates from Mars to Earth. The speed of transmitting that data from Earth to Mars and vice versa isn't as fast as it's shown. The speed of wave is the same of the speed of light, which is 299,775 km per second. Mars is 54.6 million kilometers away. So to calculate it simply, it's 5.6 times 10 to the power of 7 divided by the speed of light, which is 299,775. And now we have the answer here. It's 186.806771745, or 186.8 seconds, or you can just say it on 3 minutes. It will take 3 minutes for data to be transferred from Earth to Mars and vice versa. The movie should have shown the amount of time the data is transferred in order to teach people that waves has speed, and to also remove misconceptions and misunderstandings about data that are transferred by waves. And for the conclusion for proving or disapproving my hypothesis, I have two conclusions. For the first clip, yes, my hypothesis is true for the parachute part of the scene, but the assumption of the fall being logical is wrong. The time of fall should have been longer than it's shown in the scene. And for the second clip, yes, my hypothesis is true that data such as chats takes time to travel, especially to far distance such as Mars from Earth. The movie have shown little to non-wait period for the data to arrive from Mars to Earth and vice versa. And that's it for my presentation, and thank you for listening. Bye.